The following problem asks us to factor the polynomials. We will start with A. Since A is a quartic trinomial, I need to start with creating my x. On top, I will do my A times C value, and on the bottom, I will put my B value. My A value is 4, and my C value is negative 6. 4 times negative 6 will give me negative 24. My B value is 23. So now I need to think to myself, what two factors will multiply to give me negative 24, but add to give me 23? Those two numbers are positive 24 and negative 1. When you multiply, you get negative 24. When you add, you get positive 23. So the next step is to rewrite your original polynomial, but you're going to split up your b term with 24 and negative 1. So it will look as follows. 4x to the fourth plus 24x squared minus 1x squared minus 6. Now that we have four terms, we can do what we call factor by grouping. And all factor by grouping is dividing your four terms into two separate groups. You will then pull out the GCF from your first group. So the largest factors that go into 4x to the fourth and 24x squared are 4x squared. When I pull out 4x squared, I'm left over with x squared plus 6. You then have the factor negative 1x squared minus 6. The only thing those two share in common is negative 1. I have to pull out the negative 1 because my first term is negative. So I'll pull out negative 1 and I'm left over with x squared plus 6. I know that I successfully factored because I got the same exact thing inside my parentheses. That will be one of my groups, x squared plus 6, and my other group will be the stuff that is remaining on the outside, 4x squared minus 1. Now since these are both quadratics, I still have to see if I could factor them down any further using difference of squares. I can't use difference of squares with x squared plus 6 because this isn't even a subtraction sign. However, for this one, since there is a subtraction sign right here, I should see if 4x squared is a perfect square and if 1 is a perfect square, which they happen to be. The square root of 4x squared is 2x, and the square root of 1 is just 1. So 1 will get a plus sign, 1 will get a minus sign. And I will just bring down my x squared plus 6 so that my final answer is this. For B, I have another trinomial, but this one is quadratic, so it'll be a little bit less work. We're still going to begin with the same step. We're going to create our x, and on top we're going to put a times c. So there's an invisible 1 here, so 1 times 30, which is just 30. And on the bottom we have 11. What two factors multiply to 30 and add up to 11? Remember, if you're struggling, you could always type into the y equals on your calculator, 30 divided by x, and look at your table. The two factors happen to be 5 times 6. So, just like I did in the last problem, I'm going to rewrite my original polynomial by splitting my middle term. So I'm going to have x squared plus 5x plus 6x plus 30. And since I have four terms, I now need to do factor by grouping. So I'm going to split this into two groups. I'm going to look for my GCF of x squared plus 5x, which happens to be x. I'll pull that out and I'm left over with x plus 5. I'll look for my GCF of 6x plus 30, which is 6, so I'll pull that out and I'm left over with x plus 5. They both have x plus 5 in common, so I know I did it correctly. My two factors will be x plus 5, and then my stuff that's remaining on the outside, which is x plus 6. And this is your final answer. For C, it's a little bit different because now we no longer have a trinomial, we have a 4-term polynomial. So if you have a 4-term polynomial, you jump straight to grouping. No need to make the x and find factors. So I'll divide this into 2 groups. My GCF of 2x squared and negative x squared is x squared, so I will pull that out. And left over, I have 2x minus 1. My GCF of 6x and negative 3 is just 3, so I'll pull that out, and I'm left over with 2x minus 1. I know I did it correctly because I got the same thing inside my parentheses. So my two factors will be 2x minus 1 and the stuff on the outside, which is x squared plus 3. Now, since this x squared plus 3 is a quadratic, I should check to see if it is difference of squares, which obviously it is not because there is a plus sign. So this is my final answer.